Hello students, pleasant greetings to you all. Welcome back again to yet another video tutorial lesson from the AP3X Institute of Mathematics Education. My name is Akin, your math instructor. Primarily my channel focuses on helping a wide variety of students improving their mathematical skills from the 9th grade level all the way up to college level, but I primarily focus on helping CSEC students, that is the Caribbean Examination Council, students in the Caribbean, Grenada, Jamaica, Trinidad and Tobago, in passing their CSEC exams on a yearly basis. But of course, the skills that you learned here, the lessons learned here, can be used to apply to all different areas in math. Now in today's video we're going to be talking about one of the most important the most important aspect in math, and that is involves solving linear equations. All right, now of course equations are in every aspect of math. Sometimes you may have to create your own equations. Sometimes you're going to be given a wide variety of equations to solve. And so what I've found out by teaching for the better half of 12 years is that a lot of students struggle with certain aspects of math because the fundamental concepts behind solving equations are usually not very solid. So we're going to be hoping that the students who are watching this video today are students that are in fact having issues with this level of math, and we're going to be trying to fix those areas by walking you through some of the fundamental rules, all the tools that you need to master solving equations. I've broken this video up into 3 parts. Part 1 would be more like an introduction, part 2 would be getting into the working some problem questions, and part 3 would be doing some advanced solving of linear equations. So without further ado, let's jump right into the video. But before we do so, do not forget to hit the subscribe button below, turn on your post notification bell, leave some positive questions and comments down below, and of course hit the like button if it is that you find any sort of value from my tutorial videos. All right, so let's jump right into the topic for today. So as you can see here on screen, ladies and gentlemen, that we're going to be starting off with, of course, having a very basic understanding of what an equation is. And so on screen here from Google, actually, the definition of an equation is basically the fact that an equation is an equal relationship formed between two mathematical expressions which involves an equal sign. All right, so what you're going to be seeing mainly is going to be something stating that x is, say, equal to 2, or something like a is equal to -1, or it's going to be say y is equal to a half, things like that. We're going to be working out the values of x, unknown variables. All right, now for the first part of this video we're going to be looking at solving linear equations with one unknown, just one variable. So of course you have other types of equations such as quadratic equations, and you have also simultaneous equations, which you're going to be looking at in future tutorials. All right, now aside from solving equations, there is also another topic that is known as solving inequations or solving inequality problems. And so an inequality / an inequation is exactly the same as an equation, but with the exception that the equation produces what is known as an exact value, and the inequation or the inequality produces what are known as a range of possible solutions. So when we look at the fact that x is equal to 2, it means that the only possible value for x is that x can only be, say here, 2. But then when we look at an inequality such as x is greater than, say here, 2, or say that x is, say here, less than -4, you're looking at the fact that if x is greater than 2, there are many possible values that will cause the equation to be true. So for example, x is greater than 2, we're looking at a value such as 3, say here 4, say here 5, and we could go on and on all the way to positive infinity. Now on the other hand here, say we're looking at, say here x is less than minus 4, then you're looking at, say here minus 4, then you're looking at minus 3, then looking at minus 2. Well, it says x is less than minus 4, my apologies, so that's less than minus 4. You're looking at, say here minus 5, minus 6, minus 7, and so on all the way to minus infinity. Okay, so an equation is going to give you an exact value, but an inequation is going to give you a range of possible solutions such that when substitute any of those values, the equation remains true. All right, now I do find that when it comes to solving an equation, many students, especially students that I'm currently teaching, they tend to regurgitate information. They tend to like memorize the steps. And memorization, there's always the possibility that you're going to forget one or two rules. So I want to take the time out in this particular video here, and we're going to be walking through some of the very basic rules when it comes to solving equation. If you can take your time out to, you know, remember these basic rules, then it doesn't matter what type of equation, all these rules are going to be quite recurring. So once you understand the basic rules of solving an equation, then of course no equation in the future is going to be a challenge for you. Now it says here basic rules of solving equations and inequations. Number 1, ensure your subject is always isolated. All right, many students are not understanding the concept, the importance of isolating your subject. Now it says here in red that your subject is what you're solving for. So if it says solve for x, then it means that x is your subject. If it says solve for a, it means that a is your subject. And if it says solve for pi, then it means that pi is your subject. So your subject is what you are required to solve for. And so the word isolated means that we need to get the variable to be all by itself. We should have no coefficient, we should have no divisor, we should not have a power. All right, it should be all by itself. So therefore then, if I get to the stage of an equation where I end up with, say, x is equal to 2, it means that there should be no number in front here, there should be no number below the x, there should be no power here. If there's a power, we have to use the root to remove the power. If there's a coefficient, we have to split the difference, we have to split the product. And if there's a quotient, a divisor, then we have to multiply both sides by the divisor. So we should always have our, say here, variable isolated. Number 2, an equation must always be kept balanced, and hence whatever operation takes place on the LHS should also be applied on the, pardon me here, typo error, RHS should be on the right hand side. All right, so if I decide to say here subtract a particular number that is on the right side of the equation, then I have to also say here subtract the same number from the other side of the equation. Let's have a look at a quick example here. Let's say that we have something like, say here, x plus 4 equal 9. Let's keep it simple here. Now I need to isolate the variable x here. I need x to be alone. So what this means here is that I'm going to have to subtract, say here, 4 from the right side of the equal sign, and I'm also going to have to balance the equation by subtracting 4 from the left side of the equation here. Pardon me, I'm going to subtract 4 from the left side of the equation, so I'm therefore going to have to subtract 4 also from the right side of the equation. That will allow my equation to remain balanced, and then therefore then simply 4 cancels 4, automatically then x is going to be equal to the difference of 9 and 4, which is going to be 5. All right, so that's just a quick little demonstration of isolating the variable. We're going to go in more depth when we get into some more examples later on here. All right, and then moving on now to number 3, try to keep your subject on the left hand side, and always try to keep your subject positive. Now this is a tricky little thing here, because many instructors here on YouTube will often don't really emphasize the importance of keeping your subject on the left hand side. Now there are going to be situations, it says here, there may be situations where your subject ends up on the right hand side because you're trying to achieve one or more of the above rules that was mentioned in 1 and 2. So sometimes you're going to find that the subject ends up on the right side, such as say 2 is equal to y, and there are going to be other situations, which is the more familiar situations, where you end up with something like y is equal to 3. Now it doesn't matter if your subject is on the right side or your subject is on the left side, then as long as you have it isolated, then that's going to be the key in having an effective and smooth transition from towards your answer to that particular question. So we're going to try to keep our subject on the left hand side most of the time, but if we cannot do that, then okay, the next aim is to try to make sure that your subject always remains positive. All right, number 4, final rule when solving an inequality. This is a tricky little one here. Now I do have some strategies in which we can avoid dealing with this number 4 here when solving an inequality. It says here that if you are required to split the product or remove a denominator from a term in an equation, then the negative, pardon me, in a term in an equation, then if it's negative, the sign must be reversed. But you have to apply rule 3, and then you're never gonna have to think about rule 4. This is kind of what I would say a little bit complicated textbook definition. Let's get into the examples and kind of see how all these rules apply. Now each time that I'm going to approach a question, I'm going to therefore make reference to the rule that you must pay attention to here. All right, now we're going to be going through a series of examples, like a series of little fundamental examples of how to solve equations and inequalities or inequations. All right, now here we have the first example here. X plus 5 is equal to 10. All right, now from an English language perspective, what this means is that there is a number. There is an actual number. Let's just mark it here with a question mark. There is some number, all right? Pardon me here. All right, just a second here, guys. Okay, beautiful. So what this means is that there is some number, right? That if I were to add 5 to it, my result would be equal to 10. And not naturally, you know, from even the fundamentals of fundamental level, you're going to know that the answer is going to be 5, because 5 plus 5 is 10. All right, so basically then, in order for us to isolate x, we're going to need to say here subtract 5 from the left hand side, because it's currently being added to the x. So the only way to remove an addition is to subtract, and so the equation must be kept balanced by actually subtracting 5 from the right side. So therefore we end up with, say here, x is equal to, because 5 minus 5 is 0, so x is now left on the left hand side, and so x is equal to 10 take away 5, so the answer is equal to 5. All right, very, very easy. Now this is the correct way to teach the math. Now most times you're going to find that in certain classrooms, different teachers have different approach. In the Caribbean, from who I was, from where I was taught, from the perspective at which I was taught, I always tend to use this technique that we call the carryover technique. All right, and so what this means is then, if that I have, I'm going to just transfer this down here. Same question, but a different approach to the question. You're going to find here that as opposed to saying subtracting 5 from the left and subtracting 5 from the right, we tend to use this carryover technique here. So basically what we're saying then is that we're going to be transposing the 5 to the right side and moving the 5 away from x. So by moving the 5 away from x, we're going to end up with, say here, x is equal to 10. And please note that the equation is kept balanced. So if I'm going to transpose a positive 5. Then when it goes over to the right side, it's going to be equal to, say here, negative 5. So easily then x is also equal, say here, to 5. And you're going to find that the way how I've worked it here in blue is traditionally how you're going to be finding a lot of secondary teachers teaching this concept. But if you were to go on other channels, other YouTube channels, you're going to find that many overseas type teachers and lecturers, they often use this sort of approach here, subtracting or adding to both sides. So whichever one you personally prefer is going to get you to the answer, because they're both mathematically acceptable. All right, but for me here, I'm just going to be using the method here that is in blue. I'm going to be using this carrying over method here. Let's look at example number 2. Say we have x minus 3 is equal to, say here, 12. So what this means for me then is that I need to isolate x. So I'm going to have to move this negative 3 over to this side of the equation. And so because I'm bringing the number across the equal sign, then I'm going to have a change of sign. So this is going to be equal to x is therefore equal to 12. And so negative 3 gets transposed to the right side, becomes positive 3. So therefore then I end up here with x being equal to, say here, 15. All right, very, very easy math problem then. All right, now we're going to be looking next at a very similar question, right? But this time it's not going to be an equation, it's going to be an inequation or an inequality. And so I often tell my students that the very same approach that we use for solving an equation is the very same rules that we use to solve an equation or an inequality. So same here, I'm looking to find the value of x. I'm therefore going to have to transpose the minus 2 across the inequality sign, and so therefore x then is equal to, say here, not equal, pardon me, x then is less than or equal to, say here, 4, and so negative 2 comes over, becomes positive 2. So therefore then what do I have here is that x is less than or equal to 6. All right, very, very easy math problem so far. Hit the like button if it is that you're getting some value already, and we're not even halfway through this video. Now let's look at another equation here. We are x plus 9 is greater than or equal to, say here, 5. So to solve this equation, then we're going to be transposing the positive 9 over towards the right side here, and so we end up with x is greater than 5. Notice that the plus 9 gets transposed over to the right side, so we end up with 5 take away 9, and so easily then x is greater than negative 4. All right, 5 take away 9 is negative 4. Now bear in mind, guys, that what we're looking at here is the approach to solving the equation. We're not going to be looking at, say here, writing the answer in a set builder notation, or say here, write your answer and indicate it on a number line. That's not the purpose of this video. The purpose of this video is to give students a clear understanding of how to approach solving the equations. Later on, we can look at solving the equations and writing the answer in interval form, or writing the answer on a number line, or writing the answer as a set builder notation, so forth and so on. All right, beautiful. So that is the approach that you take when there is a unwanted value that is attached to your indicated subject by addition, or say here, subtraction. We use this carryover technique. But if you wished to use this subtract both sides or add to both sides, then by all means, if that's your personal preference, no problem. As long as you get to your solution, I'm okay with that. All right, beautiful. Let's move on now to section 2 of solving equation, which is what we know as keeping your subject positive. Now, I did mention to you earlier that I'm going to make indications to which rule takes place here. And so what we're looking at here is it says that we should try to keep our subject on the left hand side and try to keep it positive. Now, once your subject is, if your subject is not positive, then you would not have solved for the variable, because most times the question is not going to say solve for negative x or solve for negative y. If it does say that, then okay, keep your subject negative. But most times you're going to find that your subject should always be positive. Now we're going to take a look at an approach, and as simple as this may be, you're going to find that many students at the lower level struggle with solving questions like these. I'm experiencing this currently at the point of making this video. Many of my students struggle with how to solve this very basic equation. Now, how do we approach it? What I find in my analysis and marking test papers, classworks, I find that a student tends to get the basic understanding of isolating the variable. So what they'll do is that they'll go ahead here and they will transpose the 2. And so oftentimes I find that when they transpose the 2, there is the thought that this minus sign here belongs to the 2. So one of the mistakes that I find that students make is that they'll say y is equal to 10 take away 2, because in their mind, 10 plus 2, right? So in their mind, what they've done is that they've transposed the negative 2. Now, here's the knowledge, guys. A sign that appears before a number or before a term belongs to the number or the term. Okay, so this minus sign here, it is not attached to the 2. It does not belong to the 2. The minus sign here belongs to the y. Now, there is no sign that is indicated in front of the 2, but it is an assumption that the 2 is going to be positive. So in this case here, if you do decide to transpose the 2 here, then you're going to end up with, as opposed to being plus 2, you're going to end up with, say here, minus 2, because you transposed the positive 2. And in the same breath, remember that when you transpose the 2, you left the minus sign in front of the y. So the y is going to be negative here. And so the purpose of this section of the video here is to prevent students from having this sort of setup. Now, if you know what you're doing at an advanced level, most advanced math students will know how to go around this, because we already know that the y here has a 1 in front of it automatically, right? So basically then, if we wanted to get a positive y, all we had to do here was just divide both sides here by minus 1. And so that's equal to 10 take away 2. That's going to be 8. And that's going to be 8 divided by minus 1. All right. And so minus cancel minus 1. Minus 1 into minus 1. Positive 1. So that leaves us with, say here, y. And so y then is equal to 8 divided by negative 1 is negative 8. All right. And so that works. That's okay. That's fine once you know what you're doing. But there's always a way to make your answer, or to get your answer in an easier form. Now, let's just quickly transfer this question here to a different approach. Now, here is where the knowledge of always keeping your subject positive will get you to your answer faster in one line. This took 1 line, 2 line, 3 lines to get to your answer. So we're going to get this in about 2 lines or so. So here, what we're going to be doing then is, since we now recognize that our subject is negative, rather than transposing what is connected to the subject, as we've always been doing, rather than transposing what is connected to the subject, we are going to instead transpose the subject. We're going to be swapping position, or what I call a double transposition. So I'm going to swap the position of the negative y with the 10. So therefore then what I'm going to have is then, notice I didn't interfere with the 2 remains, but notice that 10 moves itself over from the right side to the left side, it was a positive 10, so it's going to become a minus 10. And notice then that negative y gets transposed to the right side and it becomes positive y. So therefore then easily 2 take away 10 is negative 8, and that's equal to y. So notice how we got to our answer easier in one line, less complications there. Let me know your thoughts in the comments. Which method do you prefer? Remember that when we have y is equal to minus 8, it is the very same thing as saying minus 8 is equal to y. It's just that method 1 automatically keeps our subject on the left, but method 2 keeps our subject on the right. Either ways, we are correct. All right, let me know your thoughts in the comment section below, guys. Which method do you prefer? For the purpose of this video, I'm going to be using, say here, method 2. At all times, I'm going to always check to see if my subject is positive. If it's already positive, then I'm going to transpose whatever is connected to my subject. But if it's negative, I'm going to transpose my subject, or I'm going to swap position with my subject. All right, example number 6 here. 7 take away y is greater than or equal to negative 4. How do we solve this? Now, the very first thing that I look at before solving an equation is that I always check to see if my subject is negative or is my subject positive. Now you'll see here that my subject has a minus sign. So right away, that kind of tells me that, okay, then I'm going to be swapping the position of my minus y with the negative 4 here. Okay, so then for me then, I'm going to have 7, negative 4 comes all the way over, becomes positive 4, and that's going to be greater than or equal to y. All right, and then easily then 7 plus 4 is 11, and 11 is therefore greater than or equal to y, or you can read it the other way, y is less than or equal to 11. I have kept my subject, say here, positive, so I have gotten the right answer. Now, we must also look at the situation where sometimes a student does not remember that information. What happens then when the student accidentally then, say here, leave the subject negative, especially when it comes to an inequality? What we're looking at then here is that, okay, let's go down here. All right, so let's just erase this space here and just try it the other way. All right, so what happens now if my student, or if a student leaves the subject negative in an inequation? What's going to happen here is that if they go ahead and they swap, say the minus 7 here on that side, going to end up with negative y, and that's greater than or equal to negative 4. Notice now the minus set, the positive 7 comes over and becomes negative 7. Okay, so then we end up with minus y is therefore then greater than or equal to negative 11. Now, this part of the paper, this part of the question now is where you have to remember this very subtle information here. Right, and so what happens here is that minus y, as we said here, if it's negative, we're going to divide by minus 1. This now, because you're dividing the inequality by a negative coefficient, then we must reverse the sign. So that's less than or equal to, as opposed to greater than or equal to. And that's going to be minus 11 divided by minus 1. So that negative into the negative gives a positive. So y is therefore, as opposed to being greater than or equal to 11, is going to be less than or equal to 11. All right, and if you can see that when I did the question earlier, you recognize that I had, say here, the y on this side, we had, say here, 11 was in fact greater than or equal to y. That's what I had earlier. but now you can see that it's on this side here. Y is less than or equal to, say here, 11. All right, so you just have to remember that if you find yourself dividing both sides of an inequality or an inequation by a negative value, then that's the time you reverse the sign. If it's not, then of course you keep the sign as it is. All right, beautiful. Let's go on to, say here, example number 7. And it's a very interesting question, because this is where now we're going to be introducing yet another effective tool that you need to keep in mind here. This is what I call directional transposition. And so this kind of brings up, which direction do I transpose? We're looking at an inequation here with more than one of the same unknown. So here we have 7y on the left and we have 8y on the right. We need to get the y's to be on one side or either side of the equation. Now, is there a right side or wrong side to get? Well, it really kind of depends. If you are able to remember to reverse the sign when it's a negative coefficient in front of your unknown variable, then okay, no problem. If you can remember to reverse the sign, no problem. But if not, I strongly recommend that you always transpose the unknown variable in the direction of the larger coefficient. Okay, always you transpose in the direction of the larger coefficient. What do you mean by that, Akeen? It simply means then that I have a choice. I can either bring the 8y over to this side where the 7 is, and then bring the minus 2 over to where the 8y was. That would then cause my subject to be negative because I'm bringing the 8 in the direction of the smaller number. So most likely I'm going to end up with a negative subject. And if you're okay with reversing the sign when the time comes, then this method is also quite effective. However, let's say then that you transpose the 7y then in this direction, and then transpose the minus 5 over in this direction. That will cause my subject to be positive. So let's do that then. Let's keep it simple. Notice then that I brought the minus 5 to the left side. If I wanted to, I could just write down the minus 5 in front of the minus 2. Or, as some of my students ask, what if I wrote the minus 2 followed by the minus 5? That is also okay, as long as it's over here and we change the sign. So we can have minus 5. If you want to put it in front, you're going to end up with, say here, 5 minus 2. If it goes in front of the minus 2. And of course, if it goes behind the minus 2, it's going to be minus 2, say here, plus 5. And therefore, that is less than or equal to, say here, the 8y is already on the right. So I'm going to simply bring the 7y over towards the right as well. So then we end up with a very organized equation. Minus 2 plus 5, that is equal to 3. That's less than or equal to 8y take away 7y is y. Now in this case here, I do not need to split. There's no negative coefficient in front of the y, so my answer remains as 3 is less than or equal to, say here, y. So I got my answer in 2 lines. Now again, we have to bear in mind that some students are not always going to remember those simple details. So their first guess is to, say here, transpose the 8 over towards the left. So you have 7y take away 8y, and that's going to be, say here, less than or equal to negative 5. And again, I'm going to bring the minus 2 over. It's going to become plus 2. So then I'm going to end up, say here, 7 take away 8 is negative y. And that's going to be less than or equal to minus 5 plus 2 is minus 3. So now I end up with a negative subject, which means that I'm going to have to divide both sides by minus 1. So then if I go ahead and I divide the left side here by minus 1, I'm going to have to reverse the sign and divide the minus 3 also by minus 1. So therefore then I easily end up here with a positive y, and then that's going to be greater than or equal to, as opposed to being less than or equal to, y is going to be greater than or equal to negative 3 divided by negative 1 is positive 3. So I end up with the same answers. It's just that for this one here, I'm reading from the right towards the left, and then I'm reading here from the left going towards the right. Notice that the sign, the mouth of the sign is open to the side of the y. So you know that both equations are, inequalities are saying the same thing. Alright, and funny enough guys, that these are some of the fundamental rules that students really do not understand. This is the reason why you are having so many challenges with solving equations, because those simple little mistakes that you make is what will cost you when you're doing more challenging questions. All right, so this page that we're looking at here will bring us to the end of this video. We're going to be basically rearranging equations to form new subjects. Now you have to understand, ladies and gentlemen, that when it comes to equation, there is a difference between an equation and a formula. All right, now not all equations are formula. For example, all of these examples here on screen, they are all equations, because we have a mathematical statement here on the left being equated to another mathematical statement here on the right. So it is an equation, but it's not a formula, because we don't know what x represents, we don't know what t represents, we don't know what q represents. So this is not a known formula. All right, this also is not a known formula. This is not a known formula. It's not an axiom. Okay, it's not a known formula here. These are all equations. So we can't necessarily solve these equations, and we can't solve it simply because we have more than one unknown. The examples that we were doing earlier, we had only one unknown: x, 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 y, y. We only had one unknown. So now we have two or more unknowns. So the most that we can do here is that we can actually rearrange the equation. You're going to find that this is a skill set that you're going to need when you start to work out algebraic equations with more than one unknowns. So now what we're looking at here is x minus t equals q. We are to say here solve for x. I need to erase this word here because this equation cannot be solved. We have to say here for x, meaning that we need to get x to be isolated. And so this is quite easy. It's very similar to example number 1. We're just going to isolate the x by moving the t over towards the right side. So then we end up with, say here, x is equal to q negative t becomes positive t. And so that is our answer. We have rearranged the equation to cause x to be the subject. All right, now provided that we are given a value of q and a value of t, then we can therefore solve for the value of x. But for now, the most that we can do is solve for x, or rearrange the equation for x. Very similar here. We're looking at an example, say here v plus u is equal to r, and we're going to be solving for u. All right, again, removing the word solve because we won't get an actual answer for u, but we're going to get an equation that can actually find the value of u. And so to do this, obviously, we're going to have to move the v over towards the right side again. So then we end up with, say here, U alone on the left. And so notice that the V went on the right and attached itself to the V and attached itself to the R. Therefore, V is now negative. The answer then is in fact U is equal to R take away V. Again, if we knew what the value of R was and we knew what the value of V was, then we could subtract the value of V from the value of R and we would know what the value of U is. All right, so it's very, very similar to what we were doing earlier. It's just that for this one, we are not going to get an exact answer, like an actual numerical value. We're just going to get an expression as opposed to a numerical value. All right, this one also, now they have another way that they love to really write the questions, and this throws off a lot of students that don't have strong fundamentals when it comes to solving the equation. Make X the subject. So now what we have as the subject here is 7. We have a constant as our subject because the constant is the only one that is isolated. Now we are to make X the subject, but then that means then that I would have to get rid of the pi. Now the thing is, and if we pay close attention, that if we get rid of the pi, what happens here is that we leave our subject negative. And prior to this particular section of the video, we looked at the importance of why we should always keep our subject positive, because number one, we are more efficient with our answer and we get our answer in less time, and we don't have to remember subtle information like reversing the sign. Now for this particular question here, if you notice that it's at less than or equal to, so okay, if you choose to transpose the pi, okay, we're going to be left with negative x is less than or equal to 7. Pi was positive, so it becomes negative, so it's 7 take away pi. And so therefore, if we divide both sides by -1, then we're going to be ending up here with 7 take away pi divided by -1. Now, the moment we divide by -1, remember that we have to remember to reverse the sign. So then we're going to end up with -1 cancels here. So x is therefore greater than or equal to -1 into 7 goes -7 times, and -1 into negative pi goes pi times. So we end up with pi take away 7, or -7 plus pi. We don't want to have to go through all of that. It's very simple, that all we have to do here, guys, is pay close attention to whether or the intended subject is positive or if it's negative. So as opposed to moving the pi, I'm just going to swap the position of -x with the position of the 7. I'm going to swap position. So pi, +7 comes over, -7, and that's equal to -x goes over, becomes +x. In one line, I was able to find out that pi take away 7 is in fact equal to x. So we get to our answer more efficiently once we can, say here, identify whether our subject is positive or negative here. All right. And then finally, then let's look at, say here, this final example here. We're looking at 5 take away z is equal to v minus r. Very simple question here. It says express z in terms of v and r. Many times this throws off a lot of students. Sometimes if you're not a teacher and you're not in the classroom, you won't recognize how these English mathematical statements here throws off students. I've seen where many students, they have very good understanding of transposition, but when you write the question in a certain way, if they're not experienced in knowing these questions and how they're asked, then it throws them off completely. So express here z in terms of v and r. Once you see the word express, it means to make, is to express, is to get that particular variable by itself. So here again, we can see that if we transpose the 5, we're gonna have to work too hard to get to our answer. So we're gonna go ahead and we're gonna leave the 5 on the left. We're gonna therefore bring the v all the way here, so that's gonna become minus v, and I'm going to bring the negative r also on this side here. I'm gonna end up with positive r, and then easily then you're going to find here that I transpose then the minus z, which is now all by itself, and it becomes positive z. So therefore then easily my answer is 5 take away v plus r, that's equal to z. And that is it. That is my result. All right. So all of what we've discussed in this particular 3/4 of an hour video is that we've just learned how to improvise when it comes to solving equations or rearranging equation. This is in fact part 1 of this video. In part 2, we're going to be looking at, say here, splitting the product. Splitting the product in an equation. It's a very different setup. And then of course we're going to dive off into splitting the product when it's a fraction, when it's negative, when it's positive. Also looking at inequalities as well. All right. And then hopefully then we're going to be looking at multi-step equation in part 3 and part 4. All right. So I do hope that this particular video was of some value to you. Do not forget to leave your thoughts. Hit the like, leave your thoughts in the comment section below. Hit the like button if it's of some value to you. Please do not forget to share this out to your mathematical communities, and let's continue to improve in our math skills. I do hope that this video was of some value to you, and hope that you have now mastered the fundamental skill set of solving an equation. So until next time, take care. My name is Apex, and I'll see you in another tutorial video. Take care, guys. Bye-bye.